Okay, it's stats o'clock here at Nick Does Maths. We are going to do a little bit of a test for independence using the chi-square distribution. So the dean at a university thinks that gender is independent of the class of degree received. That's your grade at your degree. So the university takes a sample of 240 male and 80 female. Bit of a discrepancy there, wonder why, but there you go. Students, and this is what they get. They split them in percentages. So 22.5% of male students get a first, 35% of males get a 2-1, 42.5% of men get a 2-2, and same thing for females. We're going to check this idea that is completely independent at the 10% significance level. So let's set this up. First of all, H0. I don't have a ton of space. Gender and class are independent. And H1, gender and class are not independent. Okay. Now, this table isn't so good for me. It isn't so good for me because these are in percentages, and I want to be able to combine them. I want to know what is the odds of getting a first overall, a 2-1, and these of course are percentages of different totals. So the first thing I need to do is turn these into numbers. So I need 22.5% of 240, 35% of 240, etc., etc., etc. Now, because I am a sneaky sausage, I am fairly sure I have already done this. So 22.5% of 240 is in fact 54 students. 35% is in fact 84, and 42.5% is in fact 102. Yes, that makes about sense. All right, and we should see that the total there is 240. 20% of females, 80, that is 16. Yep, this works out nicely for me. Okay, and then 34, and then 30. Okay, all right. Put that there because we're going to need it for in a second. Right. Now, the idea, as always, is this. So, for example, the probability of getting a first is going to be 54 plus 16. 54 plus 16 is 70. Out of a total of, if we add them all up, there were 240 male, 80 female out of 320. The probability of being male is 240 over 320. I will do this calculation for one of these. So the probability of, if they are independent, so we assume under H0, first and male will be probability of getting a first times the probability of being male. So, and then I scale this up by multiplying it by 320 to get the number of people who will get a first and be male. So I'm going to do all of those in red. So if I do that, and then multiply this by 320 to get the expected number, that would be 52.5. So if it was independent, I can just say the probability of first and male is the probability of first times the probability of being male. That is the key here. That is what H0 is telling me because it is independent. So I can just multiply these two probabilities. And again, the first is because how many students got a first? 54 plus 16 overall. We'd do the same thing for a 2-1. Probability of getting a 2-1 would be 118 over 320, and so on and so forth, right? So we get the overall probability, scale it up, we get 52.5. Now, the more eagle-eyed amongst you, or those that like the formulae they give you in a book, you will notice that that 320 does cancel out there. Do with that as you will. So I'm going to put these in red. So my expected ones are going to be in red. 52.5, 88.5, 99, 17.5, 29.5, and 33. All right. if you are doing this in sort of an exam situation, you would not be called upon to work out every single one of these. Normally it's one or two you'd have to work out. Okay, so these are in blue, we have the actual frequencies we have, and if they were independent, these are the ones that I want. These are the expected ones. Now, how many degrees of freedom do I have? Well, the issue is I don't have that many, because I've assumed that whether I'm blue or red, the total of each of that line is 240, the total of that one is 80, and I've assumed, I've made sure that the totals of the columns match up. So in fact, as soon as I've got these two numbers, that number is fixed. As soon as I've got that number, that one is fixed, because these two numbers have to add to 70. So if I've got this number, that one's fixed. If I've got that number, that one's fixed. If I've got that number, that one's fixed, and that one. So there's only 2 degrees of freedom. I can only pick 2 of these before I can solve the Sudoku, because I know what all the totals need to be. So in fact, I only have 2 degrees of freedom. So my degrees of freedom is 2. You also, again, for those of you that enjoy a good formula, number of columns minus 1, number of rows minus 1. So it is 2, right? You can also do it that way. So we're going to work out my chi-squared statistics, which is the sum of observed minus expected, all squared, and then rescaled over expected. And I can tell you, if I remember how, test chi, test chi 2a. We get a chi-squared here of 1.45. A chi-squared of 1.45. Now, what is my chi-squared with 2 degrees of freedom at 10%? I don't know, I'm just putting a load of numbers there. I can, in fact, do that with 2 degrees of freedom. 4.6 or 4.61, I don't know. I get to use the calculator. You might be looking at tables depending on your exam board. But the point is, so what does that tell me? It's telling me that, don't forget, this is a measure, this 1.45 is a measure of how far apart my observed and my expected numbers are, right? How wrong are my blue numbers if I'm expecting the red ones? I get a total wrongness scaled of 1.45. My critical level of wrongness, where I would think things are a bit sus, is 4.61. Now, that is way more than the 1.45 I've got. So I will say there is insufficient evidence to reject H0. Okay, i.e., my blue numbers are a little bit off from the red numbers, which is what we would expect if H0 is true. Okay, and that's okay. You'd expect a bit of statistical noise. That real world is a bit messy. So the idea is I'm off, but not by much. I'm off, but not by enough. So there's not enough evidence to assume that that's wrong. This suggests the dean is correct. This suggests the dean is correct. Bosh. And there we go. There we go. Isn't that nice? Nice, clean test for independence using the chi-squared. Again, computationally, this would end up being quite heavy if you had to do it all by hand. I did it for you. In an exam, you'd be expected to work out 1 or 2 of these at most. Please don't forget, if you find this valuable, to like, subscribe, like the video again, subscribe again, hit the notification, the bell, so you know when another one of these is coming out. And in the meantime, 'tis me, 'tis Nick, 'tis maths, 'tis done. I will see you soon. I'm going to leave now.